Awesome. Start with questions from homeworks. Does anybody have any questions from the homeworks, or you want to talk about Nick?
Can you do number 19?
19. All right, 19 says, two concentric circles are cut by the same angle. The radius of the smaller circle is 4.3 inches, and the cut arc measures 5.2 inches. If the radius of the larger circle is 5.2 inches, what is the length of its cut arc? Round your answer to the nearest hundredth. So let's start by drawing ourselves a picture. When we say concentric circles, what do we mean? Yeah, so they got to share the same center. So it's kind of like a bullseye. So we have like a big circle and a little circle. So like, we'll do that. So we're going to have two sectors created. So I'll call the first one the inner, and I'll call the second one the outer. Okay with that? It says the radius of the inner is 4.3, and its arc is 5.2. And it tells us the radius of the outer is 5.2, and we need to figure out its arc. You cool with my setup?
Yes.
Okay, so what I'm going to do is I'm going to take this and solve for theta. And I could use either of my arc length formulas, but I'm going to use the one that's in radians because, boy howdy, that's a lot simpler. So if I just divide both sides by 4.3, there's my theta. And then if I take that theta, I can plug it in here. And use that to solve for the arc. And whatever you type that through in your calculator is going to be your answer. I'm going to omit that piece, though. Does that make sense, Nick?
Yeah.
So the key observation was realizing that both sectors are going to have that same central angle. So I can use the smaller sector to find the central angle and plug that central angle into the bigger sector to solve the arc length. Yeah, Tommy.
Can you do 21?
21? Sure. So it says a pizza shop worker decides to cut a round pizza into 10 equal slices. If the diameter of the pizza is 18, what is the length of each piece of crust? Round your answer to the nearest hundredth. So we have our pizza, right? And we're going to cut that into slices. I'm going to just draw one representative slice. So we know we're looking for S. What is going to be the R for that slice? 9, because I know the diameter is 18. And how are we going to find that central angle? Because I still need that in order to find S, right? This is going to be the key here. So how many degrees are in a circle? 360. And if I'm dividing that into 10 slices, I'm chopping that up into 10 equal angles, so that 360 gets divided 10 ways. And now I can plug that into my formula. Notice since I'm in degrees here, I have to use the degree version of my arc length formula. But that'll do it. Does that feel okay there? Okay. So again, probably the key here was realizing that 10 equal slices was what I'm going to use to get my central angle.
Yeah, I was looking at it.
Yep. I think we do the same trick in geometry now. I know that's a long time ago. When you dealt with the regular, finding like areas for the regular figures to figure out what that central angle is going to be when you make your, you divide it up into all those isosceles triangles. Does that ring a bell? Maybe not. It's been a while. And if you did regular geometry, I'm not sure even how much you do with regular figures and areas there. It was a long time ago. I don't blame you if you're like, I don't know. That maybe sounds like something, but. Okay. Any others, questions? Daniel. 23. Okay. So it says Daniel is riding a bike that has 22-inch diameter wheels. If he can ride at 14 miles per hour, how many revolutions per minute are his tires going? So I'm going from miles per hour to revolutions per minute. So this is just a unit conversion problem, similar to the example we did before, but this time instead of going revolutions per second, our answer should be in revolutions per minute, but we'll set it up the same way. So 14 miles per hour. I'll start by converting hours to minutes. So we have we're in miles per minute now. The per minute part, though, is good. That's what we need. Now I need to convert miles to revolutions. I remember to do that, I'm going to use the circumference of the wheel. Now the wheel's measured in inches, so I'm going to convert miles to inches, and then I'm going to use that circumference. So we'll go 1 mile is 5,280 feet. And I know 1 foot is 12 inches. So now we're in inches per minute. That's still not quite right. So the diameter is 22. So 2 pi r inches is 1 revolution. And now it's just punch it through on my calculator. Yeah.
It's hard.
Oh, should be 11, right? Ha, thanks. Yep. The other problem, R was 9, I think. Still on, I don't know, 19 or something. Bye. Daniel, feel good? Okay. Anthony, did I see your hand?
Yeah. Do 1.
Number 1?
Yeah, just like how to, like, what's the answer?
What's the answer? I mean, it's reduced 80 pi over 180, which reduces down to what, like 4 over 9 or 4 pi over 9?
Oh, I meant 2. Sorry.
Oh, 2? I would just give it as a decimal.
Oh, okay.
Since that's not going to be easily, says answer in terms of pi when applicable.
Yeah, I used to know that.
So like all of those I would say is not applicable. I mean, you could do it, it just stinks. I would just give them as decimals. If they give you a decimal, I think it's probably fine to give your other answers as decimals. Is that good enough?
Yes.
No problem, dude. Okie dokie. Should we go on to 2.3? Well, here's the deal though, Max. Originally I was going to do 2.3 and 2.4. I'm just going to do 2.3 today.
Let's, you know what?
That seems like that's a pretty good deal, right? Like, could be worse. The reason I want to do just 2.3 today is that the skill that we're going to talk about in 2.3 is something that's really important moving forward. If you can't do the skill that we're looking at in 2.3, many of the subsequent sections are going to become problems. And they're probably going to be problems just because we have a problem with this skill. Okay, so this is one that builds on and builds on and builds on. So it's a really necessary piece moving forward. So again, like, this is a game. Make sure we can do this kind of skill. So recall from geometry, when we measured an angle, we always measured like the smallest way to do that, right? We always would look at this measurement as opposed to this one, right? Everybody remember that in geometry measured things this way? And as a result, the biggest angles that we could measure would be like 180 degrees. What we're going to do today is create a new system of drawing and measuring angles that allows us to draw an angle of any with measure of any real number. So as big as you want, as small as you want, negative, positive, whatever, bigger than 180, bigger than 360, it doesn't matter. Make it as big as you want, we can draw it. Or as negative as you want, we can draw it. Ready to see how to do this? That's the goal for today, is just accomplishing this new way of drawing and measuring, or not measuring, but drawing angles. So what we're going to do is we're going to embed our angle onto the XY axis. The vertex of our angle is always going to be fixed at the origin. And then one arm of our angle is always going to lie on the positive x-axis. We call that arm the initial side of our angle. And now let's say we wanted to measure a 190 degree angle. This is an angle that is impossible to draw from a geometry in our geometry class. We will now be able to draw this with this new way of drawing angles. Everybody is okay? Okay, so before I start drawing this, I want to ask you, how many degrees are in each quadrant of my XY axis? 90 degrees, right? So what I'm going to do is I'm going to rotate from that initial side counterclockwise and just count the degrees. So 90, 180, and then like 10 more. I'll just eyeball it. And that's a 190 degree angle. And now you might think to yourself, okay, Mr. Kulik, cool. I'm fine with that. But when I look at that XY axis that you drew, there's only 360 degrees. How are you going to do something bigger than that? Like, how would you do, 405 or something? Well, let's see. Before we move on, before I do that though, this other arm of our angle has a name. This is called the terminal side. Sorry about that. I just got so excited about the math, forgot to mention the name. So there's the initial side, always on the positive x-axis, And then the terminal side, that's the side that's rotating around the XY axis. All right, so 405. Seems like there's no way to do that, Mr. Kulik. Well, sure there is. So 90, 180, 270, 360, and we'll just go 45 more. And there's my 405 degree angle. So it's kind of like a clock, right? How do you do 2 hours on the clock? Well, you just go around twice, right? There's only 60 minutes on the clock face. If I have to do 2 hours, 120 minutes, it just goes around and around again. That's fine, no big deal. Everybody's cool so far? All right, but Mr. Kulik, you told me I was going to be able to do negative angles also. How the heck am I going to do that? Yes, we're just going to spin it the other way. So if I have negative 120, so we'll draw our XY axis. We have our initial side, and then we're going to rotate clockwise for negatives. So 90, and then like 30 more. What do you guys think? Not too bad, right? Pretty simple so far. It seems super doable. You're telling me this is a difficult skill or a necessary skill? It definitely is. We're going to draw lots of pictures in the future. And you have to be able to draw something that's like close to what it really looks like to be able to answer the questions correctly. If you have a bad picture, it makes it hard to get the right answer. Next up, why don't you guys take a minute for me and on your own papers, draw a 45 degree angle and a 405 degree angle. You can do them on separate or you can do them on the same XY axis. It doesn't matter to me, but take a minute and draw both of those just for practice sake. So I've drawn my two angles. What do you notice about these two angles? The terminal sides are in the same location, right? Now they're different angles because they have different angle measures. One of them is 45 degrees, the other is 405 degrees, but their terminal sides are in the same location. This is a special thing that's just happened for us. Let's give this situation a name. So the name we're going to give this situation is called coterminal. We'd say that these two angles are coterminal. So again, our definition would be coterminal angles are different angles. They have different measurements, but they have the same terminal side. So again, these are angles with different measurements, but their terminal sides are in the exact same location. Do you notice anything special about the numbers 45 and 405? Yes. Okay. How about how far apart are they? 360. Do you think that's a coincidence? No. Because if I have something on a circle and I go 360 degrees more, I'm still at this exact same spot, right? So that is going to be our tool if I want to find coterminal angles. If I know one angle, I can just keep adding 360 or subtracting 360, and each time I do that, it's going to generate another coterminal angle, right? So how many angles would I have coterminal to, say, 10 degrees? Infinitely many, right? Because I can just keep adding or subtracting 360 and getting a new coterminal angle each time. Everybody's okay? Let's do an example of doing that. So here it says, find two angles that are coterminal with 47 degrees. Okay. Well, I can just take that 47 degrees and add 360 to it. So 407 would be one possible answer. And then to get my next possible answer, I could just take that 407 and add 360 again. So 767 would be another one. And I could add 360 again and get another and another and another. Or I could have started by subtracting and subtracted each time. Or I could subtract one and add one. It doesn't matter. Does everybody feel okay there? Yes, Max. Yes. So I could have done 47 minus 360, gotten an answer. And I could do 47 plus 360 and get an answer. Or I could take my 47 minus 360 answer and then subtract 360 again. You could do it that way. Any combination of those is okay. Just a question of like, are you looking for one specific coterminal angle? Like maybe I'm looking for one between certain values, and that will tell you whether I should be adding or subtracting. Part B, it says find two angles coterminal with pi over 3. What's pi over 3? It's just an angle in radians, right? So if I have an angle in radians and I want to find an angle coterminal to it, can I add 360 degrees to an angle in radians? No, because the units don't match. So what I need to do is I want to start by figuring out, well, how many radians is 360 degrees? And that's what I'll add or subtract to pi over 3. So to convert that into radians, I'll multiply by pi over 180, and I get 2 pi. That's probably a good thing to remember, that 360 degrees is the same as 2 pi. You'll use that a lot, so that's a good one to just kind of remember. So now I can do pi over 3 plus 2 pi. To add pi over 3 and 2 pi, what do I have to have? A common denominator. What would the common denominator be between them? 3. So if I multiply 2 pi by 3 over 3, I get 6 pi over 3. Everybody's cool? And if I add pi over 3 plus 6 pi over 3, what do I get? 7 pi over 3.
So that's a coterminal angle of pi over 3.
Yes. And if I want to find another one, I'll just take that answer, that 7 pi over 3, and I'll add 2 pi to it, but I know that I really want to write it as 6 pi over 3. I already made the common denominator 1, so let's just cut right to the chase. So I get 13 pi over 3. What do you guys think so far? No big deal? Okay. How many of us have mid to low fraction confidence? Okay. Let me show you something you can use to help that on your calculator. If you have your graphing calculator with you and you have low fraction confidence, I invite you to take your calculator out and follow along. If you just want to follow along because you're like, hey, I just spent $100-something on this calculator, I don't really know how to use it very well, follow along as well. Everybody ready to go? So, if I type anything into my calculator with pi's, my calculator will not return me a fraction no matter what I do. Because pi is an irrational number, it's never going to deal with that. It's always going to give you a decimal. However, if I type in, and if I want to do pi over 3 plus 2 pi, if I just take the pi's off when I type it into my calculator, and then put them back on when I'm done, the calculator will deal with that. So instead of typing pi over 3 plus 2 pi, I'm going to type 1/3 plus 2. Everybody's okay with that? I'm just taking off the pi's. To get that horizontal fraction bar, I press alpha, that's the green button. I press y equals, that's the top left-hand corner. I'll pick option 1. And I'll do 1/3 plus 2 and press enter. That gives me 7 over 3. All I'm going to do now is put the pi back onto that, and I have my answer, 7 pi over 3. Did you guys see what I did? So I took, this is what I'm trying to get an answer for. So I just forgot about the pi's. I just typed in 1/3 plus 2 and pressed enter. Because my calculator can do that. Max, what's up?
So we just add the pi.
So you just write the pi in when you write your answer.
All right.
But the calculator can't deal with the pi's, but you can, right? If I just take them off, do the arithmetic, and then put it back, I can handle that, and it allows me to avoid the fractions, right? If I'm adverse to fractioning. Now, say I wanted to do this again, right? So I'm going to take that answer, that 7/3, and add 2 again. And there's 13 over 3. I'll just write down on my paper 13 pi over 3. And there's my other answer. It's a nice, lovely shortcut if you're like, ugh, fractions, I'm not very good at that. Which I understand. This is why I'm showing you a way to kind of avoid that. Now on your quiz or your test or whatever, do I expect to see you showing me the work on how you make a common denominator to add fractions? No, man, it's a 6th grade math skill. You're free to skip over showing that kind of work. It's not germane to what we're doing here. That's fine to zip past. Is everybody okay? Cool. So, last time we assigned 1 through 42 as the homework set. That's covered sections 1 and 2. The homework for section 3 is just 43 and 44. That would be part of next Sunday's problem set. We'll add to that next week as we cover more sections. In addition to that, though, I also have created a delta math assignment for section 2.3. Let me show you what that looks like and how to do the problems. So there are, this is the chapter 2 delta math number 2. There's 4 types of problems I'm going to ask you to do. The first one asks us to estimate the angle. So it wants me to give them the value of this angle within 10 degrees. So if I look at this, that looks like maybe a third of that first quadrant, right? So maybe I'll say that looks like maybe 30 degrees. And it said, okay, the actual number was 28, but I was close enough. If you guess wrong, it'll just make you keep doing them until you get some. You need 5 total right, you know. The next type of question, it's going to be asking us to draw the angle. So negative 34. So in the picture, I'm going to grab the yellow. You know, I'll left click on my mouse and I'm just going to make that like about 34 degrees. That's probably a little bit too much, maybe there. I'll hit submit answer. And it says correct. I gave it a negative 25. Woo! But it was within 10 degrees, so I was good. That's all you need to do for those. Everybody okay there? We'll do one with bigger angles, so 944. So since it's positive, I'm going counterclockwise. 90, 180, 270, 360, 450, 540, 630, 720, 810, 900, and then 44 more is like halfway. Maybe put it to there. Submit. Took it. I gave 946, so I was good enough. Is everybody okay with how to do that? And then the last one is going to ask for an angle coterminal, and it gives you a bound. So I need an angle coterminal to 1051 between 0 and 360. Is that angle coterminal need to be bigger or smaller? Smaller. So I'm going to be subtracting 360 from it, right? So if I subtract once, that's not small enough because it's not less than 360. I'll do it again. That's small enough, though. That's less than 360. So I type in 331 and press OK, and it takes it. Those are you got to do 5 of each type correctly. No penalty for wrong ones. Don't be frustrated with the within 10 degrees. You're going to make some mistakes and have to do a couple before you kind of realize how careful you have to kind of be. The remaining 45 minutes or so of class, you can be working on any one of those 3 things, whether it's the 1 through 42 if you're still working on that. You can work on the 43 and 44 if you're still working on that. Or you can work on the delta math. Whatever your preference is, that's fine with me. I want to do one more thing before I release you to work, though. So on Monday at midnight is due the 1 through 42. We're going to turn that into OneNote. Let me walk you through how to do that if you're doing your homework on a separate sheet of paper. Everybody okay? We listening?
Yeah.
Okay. If you want to follow along and just do a practice run, even if your assignment isn't done, if you just want to, follow along with some whatever, just to practice the process, you're welcome to do so. To do this, to get paper into OneNote, you're going to take out your cell phone. It is okay to take out your cell phone right now. I'm giving you permission to do so. If you want to follow along, take out your cell phone. The best way to do this, if you have an iPhone, is using the Notes app. Once you've opened the Notes app, you'll want to open a fresh note in or from your iCloud folder. So if you're paying that extra 99 cents a month or whatever for the extra memory, because you can't have enough backup space physically on your phone, you have to pay Apple. I think they've made it so basically you can't ever have a backup without paying for it. You have to open an iCloud note, and if you click somewhere in the note on where your keyboard comes up, above that is a little picture of a camera. Click on the camera, and you'll pick Scan Document. If you do that and you just hold it over the document, it'll automatically capture the document as a picture, and you can keep doing that over and over and over, and you can get all your pages into one PDF. Once you've done that, say, close that note, open up the PDF, and email it to yourself. Is that okay so far? So once you have that email to yourself, let me show you how to get that from the email into OneNote. So this is just an email from a student that sent me their homework. So I'm going to click on the attachment. I'm going to click on the little print button up here. And then for whatever reason, it opens a new thing, makes me do it again. So from the destination, I'm going to pick OneNote desktop. You might have to do the see more and pick it from there, but you want the desktop one. And then you just hit print. It'll open up OneNote if it's not already open, and it'll give you this pop-up that asks you, where do you want to put this thing? So I go down to my 7th hour notebook, and maybe, Abby, I'm going to use you for a demonstration. I click on my name and pick the homework option and hit OK. And splat, right in there, beautiful, all in one place. I would just go to the top here and change the name of it from printout to chapter 2 problem set 1 or whatever it is. Is everybody okay? If you want to practice this now, and if you run into problems, ask. You're welcome to do that. We'll have phones out here for the next 10 or so minutes. If you want to practice after that, we're going to put them away. If you're not interested, you're like, I think I got it. I've done this before. Totally fine. Start on whatever homework you feel like or is most pressing for you. 1 through 42, 43 through 44, or the Delta Math. Any of them's good.
Is Delta Math due on Sunday as well?
So the Delta Math would be due Monday midnight. We don't have we don't have school on Monday, so we'll push the due date back a weekday.
All right.
Everybody feel good? Okay, I'm going to stop talking now and let you guys work on whatever's your highest priority item. Abby, I'm going to delete this extra page I just put in there. Bathroom's cool.